Okay, I was on a walk today, and I had a idea, and I want to share it with you. Sorry, moving that chair making noise. I want to explain the idea with you. The issue is, well, a thought on my mind is how do I manufacture the Mark II? And beyond, of course, a little bit, but mostly the Mark II because that's what comes after the Mark I. Mark I, made out of aluminum, welded together, 100% aluminum. You know, you get that. You've seen that. This one, the Mark II, the reason I was able to do the Mark I is because I was using a one-axis machine and then tabbing it together and welding it together. So you have to hit like multiple axes, right? So for a while, I was considering using a 5-axis machine. But even then, I couldn't figure out how to do it without starting with giant billets of initial material. And that's a lot of machining to do, very wasteful, really hard. You need a big badass machine to do it too, or it would just take forever. And you just need it for the large size. So CNC machining the entire thing wouldn't work. And then I was thinking maybe you can machine it in pieces and then rivet it together. Not a terrible idea. But I think I figured out, well, I'm almost certain I figured out a better way to do this. And I'm actually really excited about it. My friend Tim, who if you've followed the channel for a long time, know about him. He made a 3D printer before you could buy 3D printers. He literally did it before like the internet was like huge. I've seen it, it's crazy. He's a smart guy, he likes to fabricate. And we talk a lot. And he was always like, why don't you make it out of carbon fiber? And carbon fiber is awesome and I would like to use it, except I don't want to make it out of panels, right? And actually, before I talk about carbon fiber, which I'm going to come back to, I want to talk about one other thing that has been on my mind. And if you have the suit made entirely out of metal, you know, ultimately I like to manufacture it out of like titanium, right? If you have a suit made entirely out of metal, if you get hit or something, right? Iron Man fighting people, bam, get hit, smashed. If it bends, it'll completely lock out that part of the suit. And then that suit will lose full mobility, right? I mean, you probably won't be strong enough to move it. And it would also lock out your human mobility, which is kind of the key, I think, here. So carbon fiber has a really high tensile strength, but it does something else interesting too. And if you know about this, if you know a lot about carbon fiber, you probably are guessing what I'm about to say, is that carbon fiber, it's really, really, really stiff. Which means for a given load, it moves very little, like very little. It's one of the smallest like moving materials like that. So if you made a suit out of carbon fiber and you got hit, it would either not move, and then if you got hit hard enough to break the suit, instead of metal, which would deform and then lock out a joint, most likely. I mean, I guess parts of it could dent, but it would lock out that joint. Instead of that happening, it would just break. And then, hopefully, it would just kind of dangle there. It would like essentially shatter, almost like glass. The fabric inside would still be there, but it would be flexible. It would actually move around and stuff because it would then be made out of fabric. So you potentially would not lock out a joint, or not lock out a joint as bad as if it was metal, which is cool. So you couldn't make the joints out of metal, out of carbon fiber, because they're too smooth. So you'd want to do all the structure in between out of carbon fiber, and then you'd have these fail safes where if you get hit, and the suit would absorb the damage, and then it would break instead of, which make it easier to get out of, and then also, so you want to get locked in a position, so you still have mobility via your own human power, right? So that's all really cool, but I still didn't understand how to actually make it out of carbon fiber. And then I was walking, and I had an epiphany. You 3D print a substructure using not an FDM printer because it doesn't have high enough resolution, but you use one of those SLS printers, like the Formlab printer, and it pulls it out of a bed of resin. And there's a lot of printers like this, and there's one, like the most expensive one, which is like $130,000, can print parts in like 2 minutes. But most of them are really, really slow, which is a problem. But you could have a fleet of them, essentially, like a few of them, so you could print constantly. Then you print these parts out. They'd have inserts where then you would glue in machined parts and then you wrap the entire thing in carbon fiber, making it super fucking strong. You'd make the parts, because they're 3D printed, can form fit to me perfectly. I'm not limited by having to attach multiple axes and stuff. I can like custom fit it to me. I can make these shape exactly what I want it to be because it's 3D printed and you don't have to machine it. And then, yeah, that's pretty much it. It's pretty awesome. There's one other thing though that I didn't mention, which is like armor, because eventually I want this thing to be armored, and I think I still want that to be metal. Well, I do want that to be metal. I want it to be titanium for a variety of reasons, but it just absorbs damage better than carbon fiber. So then you'd have also parts in the outer part of the suit that would have bolt-on places, and then you'd actually bolt on the armor on top of the carbon fiber. At one point I was thinking about making the base layer carbon fiber and the outer layer titanium for this reason, but then you can't do that because when the load is being pulled through both layers of the suit, the load will be transferred all to the carbon fiber because it's not allowed to flex, but the titanium can flex. So it'd be like holding on to a rubber band and like holding onto a straight rubber band and holding onto a straight piece of steel. Like you couldn't put any load on the rubber band; it would just fold away in the steel. So that doesn't work. But if you make both layers out of carbon fiber, and you could add other parts to it, you could add some Kevlar, you could add some glass. You could add some glass, which actually has a higher tensile strength than carbon fiber. You could make it a multiple layered composite. You could get creative with it. But for the rigidity though, is carbon fiber. So you probably want to make it mostly out of carbon fiber. But anyway, you can bolt on the armor, and that's where you want metal, think like a tank. You want that thing to be able to absorb rounds and break off and mold and push and absorb energy. And the robustness of metal is just far higher than a composite. But then if you got hit something so hard, you would want the suit to break, and that would also absorb a little energy, but then it would just dangle there and you'd still be able to move around. That's actually kind of how it looks like Iron Man's suit falls off in the movies. It like shatters and kind of breaks off of him. If you actually go look at it, it doesn't like tear and twist. It like breaks off of him. And they have it looks like it's metal that's breaking. Metal doesn't really break like that, but it would act that way if it was carbon fiber, which is pretty cool. But it would dangle. So you'd have to but you could have some kind of tool on you, in your finger or something, like to cut off the carbon fiber, like a spinning tool. Cut yourself out of the suit, get out of the suit, you know? There's ways to do it. It'd be pretty cool. I don't know. That's the idea. I'll show you really quick. I have a couple of visual aids to help with this. This would be like the chest piece if it was like rolled flat. And so here you can see the hash marks would be the carbon fiber, and then there's these tips that attach to the front and the back, and those would be machined, and then these right here would be exomuscle inserts, so the artificial muscles I've created that are really, really high power. This would be like an insert for that. You'd have like all this surface area. You'd have all this surface area in here for the carbon fiber to overlay, and then this would be like the part in here, right? This would be the metal part. So this would be made out of like ideally titanium, but on the Mark I, probably aluminum. And then these like keys, to keep it from twisting and stuff. And this is all be glued into place into the 3D print and then covered in the carbon fiber. And you have to cut out these holes and stuff. There's ways to do it. And then here is a arm, like this would be like the end piece. This would be like the end cap over here. And if you made these on a 5-axis, which would be awesome, you can machine in like awesome parts like this in here and put in some really cool geometries. That allow it to grab on better. But if you don't, I could literally do this on my machine if I need to. So I can make this on my CNC. And I can make potentially some of the exomuscle inserts on the lathe, finish them on the CNC. I have actually, it'd be better with better tools, but I could do it with the tools I have. The only tool I would need, I guess 2 tools, wouldn't be a suite of tools, would be a setup for doing carbon fiber, which would be like a suite of systems for that. So I have to develop that out in the shop, which is not, crazy expensive. I already have a vacuum pump. So, I could do that. The 3D printer, that would be the other tool I'd have to get. And like I said, it'd be better to have more than one of them. But you could, in theory, do it on one. I could design it and then just let it print for fucking 4 years. Wouldn't be the best way to do it, but it probably wouldn't take that long. And then the other thing cool about 3D printer is you could do like a bunch of lattices. You have to get fairly creative in Fusion 360, but I think that's something I could do. You could also, actually, what you could really fucking do is you could generatively design them. And if you make really, really strong structures. And then it'd be really cool if you do them like in a honeycomb. That'd be ideal. It's hard to do. You could do it manually. You could do a little bit of a honeycomb with generative design. You could do that, you know, so you could do some really, really cool stuff, and they'd be very, very strong, very rigid. You could do a bunch of tests on the, bunch of simulations on them, and make them not only designed for me good, but strong too. Or you could generatively design them. I mean, that would actually be a really cool way to do it. So you could have these generatively designed parts that you just make all these bodies around and say the points you need it at, and kind of let the Fusion 360 design it. Yeah, there's a lot of ways to do it, which would be very, very cool. But I think this is the way to do it. I think it's the way to do it. Obviously, I'd have to learn how to set up composites and stuff. But I've watched a lot of videos on that. I've read books on it. So I think that's something that could be done. A little ways off, obviously. Got to make the rest of the suit first, which is a lot of labor. And this would be a lot of labor too. It'd be great if I had someone help me. But you know, this is the idea. I'm pretty sure this is the idea I was looking for. So I'm like 98% sure, roughly, this is how the Mark II is going to go together, which is really cool. Really cool. Yeah. Yeah. And it's also a little bit easier, I think. The parts are a little cheaper than buying, like I said, like a giant 5-axis machine, which, you know, and also the material cost on that would be insane. So, you know, it's a cost-effective, fairly time-efficient way to do this. So it's pretty cool. Pretty cool. Yeah. Yeah. Bye, guys.